Let's imagine, for example, that there is truly only one optimal action. Then, as we spend an infinite amount of time running around in the world, our notion of which action is optimal over here, if we can convert them into actual probabilities, will drive whatever the optimal action is towards 1. And that just comes from all the stuff we've been talking about with reinforcement learning for all the time in this class. If we can get to an optimal policy by just experiencing things in the world, then eventually these numbers will reflect that. And it doesn't matter what the human thinks, the real world will drive the correct answer towards 1.
So you're saying that C doesn't change over time?
C could change over time, but let's just imagine it doesn't. Let's just say it's we pick a value for C and it comes out this way. If you want to say that C changes over time, that's okay, but then we're going to deal with that question by having these numbers here reflect whatever we think C happens to be. Remember, we can keep track of all the labels that we've seen, and for any given value of C that we have, we can just change these numbers appropriately.
Okay.
So it sort of doesn't matter. At the time we asked this question, I've got a distribution over actions according to the human. I've got a distribution of actions according to my experience in the world. It no longer matters what I think about the human because that is captured by this distribution. So I can just ask the question, what should I do? And here you think the answer is X.
Yeah.
Now, what if I had different numbers here?
Then I still think it's X.
Oh, yeah? What if it's this?
Well, now I could certainly justify Y.
Why?
Yeah.
Tell me why you think Y.
So, okay, so are we supposed to imagine that the pi sub A is, like, can the algorithm be wrong?
The algorithm could be wrong, but in the same way that we don't have to worry about what's wrong with the human because the distribution captures it, let's make the same assumption here. The agent, well, this distribution is going to capture all of our uncertainty about the agent's beliefs. So maybe we'll never actually see 0, 1, 0, but we'll see numbers that are close enough that I'm just going to write out 0, 1, 0.
Boy, there's a lot of ways to combine these numbers together in which Y ends up being the winner. But it strikes me that in particular, if we believe pi sub A, then pi sub A is absolutely certain that it's Y. So it almost doesn't matter at this point what pi sub H thinks, what the human thinks.
Mm-hmm. And by the way, by the same argument, if it's the case that C is equal to 1 for the human, that the human is infallible, then it really is not going to matter what the agent thinks because the human's infallible.
Well, but unless they disagree. But then we have to really believe that probability is correct.
Right. Either the probability is correct or it's incorrect. And for the purposes of answering this question, let's just say the probabilities are correct. Insofar as they are not, it'll be reflected by these distributions.
So we could never have 1, 0, 0 on the top row and then 0, 1, 0 on the bottom row because that just violates the laws of reality.
Right. So you would argue for Y.
I would.
I think that you've been using intuition so far, and I want you to do a little bit more than intuition. So I'm going to do that by writing out a quiz.